Good day to you. I am Louis de Broglie, and today I want to talk to you about something you look at every single morning of your life, and yet I would wager have never truly understood: the mirror. Now, before you dismiss this as a trivial matter, a question fit only for children or idle minds, I want you to consider something. I spent the better part of my scientific career arguing that nature is far stranger than the surface of things suggests. I told the world in 1924 that an electron, a particle, a tiny speck of matter, behaves also as a wave. The physicists laughed. They called it absurd. And yet it was confirmed. It was real. So when I tell you that a mirror does not do what you think it does, I want you to take me seriously, because the mirror, like the electron, is hiding something from you, not out of malice, but because reality at every scale delights in confounding the assumptions we carry without examination. So let us begin. You walk to your bathroom mirror every morning. You raise your right hand, and the person looking back at you raises their left hand. You tilt your head to the right, they tilt theirs to the left. You hold up a piece of paper with writing on it, and the letters appear reversed, backwards, as though printed in some alien tongue. And so you conclude, quite naturally, quite reasonably, that the mirror has flipped left and right. But here is the question I want you to sit with for a moment. Why left and right? Why not up and down? You raise your right hand and the reflection raises its left, a left-right swap. But you stand upright and the reflection also stands upright. Your feet are on the floor and so are its feet. Your head is at the top and so is its head. The mirror apparently knows perfectly well which way is up, so why does it confuse left and right but not up and down? This question, my friends, this seemingly simple question, is the crack in the wall through which a very bright light shines, and the light reveals that you have been asking the wrong question entirely. The mirror does not flip left and right. It never has. What the mirror does and what it has always done, what it can only do, given the fundamental laws of optics, is flip front to back. Let me explain this very carefully because I know how strange it sounds. I know because I spent my life dealing in strangeness, and I learned that the path through confusion is always precision. When you stand before a mirror, imagine a line on an axis running from your nose straight into the glass perpendicular to its surface. That is the axis along which the mirror operates. Your nose is close to the mirror. The back of your head is far from it. When the mirror creates your image, it takes everything in front of the glass and places its corresponding image behind the glass at the exact same distance. Your nose, which was closest to the mirror, is now the part of the image closest to the mirror. On the other side, the back of your head, which was furthest, is now furthest on the other side. The mirror has taken you and flipped you through itself, like pressing clay through a mold. Front becomes back, back becomes front. That is all. That is the only transformation the mirror performs. It is a depth inversion, a reversal along the axis perpendicular to its surface. Now, you will ask me, and it is a fair question, if that is true, then why do I see my left and right switched? Why does my writing look backwards? And this is where we must be very honest about the nature of perception and about the nature of space. This is where the mirror mystery becomes a lesson, not merely in optics, but in how human beings construct meaning from physical reality. Here is the truth. Your left and right are not absolute directions. They are not like up and down. Up and down have a physical anchor, gravity, the ground beneath your feet, the sky above your head. But left and right, they are defined relative to you. They depend on which way you are facing. And this is the key to everything. When you face a mirror and compare yourself to your reflection, you are making a mental rotation. You are imagining that the person in the mirror is you, standing on the other side of the glass, looking back. You are mentally picking yourself up, walking around the mirror and facing the other direction. And the moment you do that, the moment you mentally rotate yourself to face the opposite way, left and right swap, because left and right are defined by the direction you face. Let me give you a demonstration in your mind. Imagine I write the word physics on a piece of glass with the letters reading correctly from your side. Now, if you walk around the glass and look at it from the other side, it reads backwards because you have turned around and left and right are now reversed from your new perspective. The glass itself has done nothing. You did it by changing your orientation. A mirror does the same thing. It shows you yourself from the other side as though you have turned around. And when you turn around, left and right exchange. Up and down do not exchange, because up and down do not depend on which way you face. They are anchored in the world. Left and right exchange because they are anchored in you. Now here is a beautiful test, one that any of you can perform immediately after this video. Find a transparent piece of glass. A window will do. Write the word mirror on it with your finger or a pen, so that it reads correctly when you face it. Now look at that same word from the other side of the glass. It reads backwards, but no mirror was involved, no reflection, no light bouncing off any surface, just you, a piece of glass, and a change of perspective. The reversal of writing that you attributed to the mirror all your life, you just produced it with no mirror at all. This is what I mean when I say that the question was being framed incorrectly. The people who asked, why does a mirror flip left and right, had already embedded in the question an assumption that was false. And when you begin from a false assumption, you can reason beautifully and still arrive at complete nonsense. This is a lesson that applies not merely to mirrors, but to all of science, to all of thought. Check your assumptions. Question the frame, not just the picture inside it. I made this very error in my own early thinking. When I began working on the nature of matter and light, I inherited the assumption that a particle is a particle and a wave is a wave, and never the two shall meet. Classical physics had decided this. The great Newton had his particles, Huygens had his waves, and the two camps quarreled for centuries. But I asked, what if this division itself is the wrong frame? What if asking, is an electron a particle or a wave, is like asking, does a mirror flip left or right? A question that misleads by its very structure. That is why I want to spend a moment connecting the mirror problem to the deeper philosophy of how we understand nature. Bear with me, the physics is worth it. When I look in a mirror, there is a particular kind of symmetry at work. In physics, we call it parity. Parity is the operation of reflecting a system through a point, or equivalently, reversing one spatial axis. A mirror reflection is exactly this. It reverses the depth axis, the one perpendicular to its surface. And for most of classical physics, parity is a symmetry. That is to say, if you have a system of objects obeying the laws of physics, the mirror image of that system also obeys those laws. Roll a ball to the left and its mirror image rolls to the right. Both are perfectly valid physical processes. The laws of motion do not prefer one-handedness over another. But, and here I want you to lean in, nature is not always symmetric in this way. In certain radioactive decays, in certain processes governed by what we call the weak nuclear force, the mirror image of what happens is not what actually happens. The universe, in its most intimate and quantum behavior, actually does prefer a handedness. Parity is violated. The mirror image is not always physically realized. I find this remarkable. I find this profound. Because it means the mirror is not merely a bathroom accessory. It is, at the deepest level, a philosophical instrument. Looking into a mirror and asking whether the reflection is physically the same as the original touches questions at the very foundation of particle physics. But let us return to the practical, to the everyday, to the experience you all have had standing before the glass in the morning. Let me now address something that many people raise when they first hear that mirrors flip front to back. They say, but wait, if I hold a sign up to a mirror, the writing is clearly reversed left to right. I can see it. Are you telling me I am imagining that? No, I am not telling you you are imagining anything. The reversal of the writing is real. I am only telling you who is responsible for it, and it is not the mirror. When you hold a sign up to a mirror, think about what you have done. You are facing the mirror. The sign faces away from you toward the mirror. So the side of the sign that faces the mirror is the back of the sign from your perspective. The mirror faithfully reflects back the front of the sign as seen from the mirror's side, which is the back of the sign as seen from yours. And since letters are not symmetrical, they look reversed to you because you are comparing the mirror image to what you see when you face the sign directly, which requires you to turn the sign around, and turning it around is what creates the reversal. If instead of turning the sign horizontally to face the mirror, you had tipped it upward, flipping it vertically like opening a book upward rather than turning a page sideways, then in the mirror the writing would appear upside down, not left-right reversed. The mirror does not care. The mirror flips front to back always, only, without exception. It is you and the way you choose to orient the object that determines which axis appears reversed. Now there is another beautiful thought experiment I want to offer you. Imagine you are not standing before a vertical mirror on a wall. Imagine instead that you are lying face down, hovering horizontally over a mirror that is lying flat on the floor. You look down into it. What do you see? You see yourself reversed, but now up and down are reversed. The image of you in the floor mirror would be upside down relative to you, because now you are facing the mirror with your front pointing down, and the axis perpendicular to the mirror's surface is the vertical one. The mirror dutifully flips that axis. It flips up and down. It has always flipped only the axis perpendicular to its surface. It is we who choose which axis that is by choosing how we orient the mirror. Stand before a wall mirror and vertical mirror, and the depth axis is horizontal, pointing front to back. The mirror flips front to back, and because of how we interpret that flip when we imagine facing the other direction, we perceive a left-right reversal. Lie over a floor mirror, horizontal mirror, and the depth axis is vertical. The mirror flips up and down, and you would see yourself upside down. This is perfectly consistent, perfectly logical, and it reveals that the mirror has no preference for left, right, over, up, down, or for any axis at all. It knows only the law of reflection, that the angle of incidence equals the angle of reflection. It bounces light back along the same axis it came in on. That is all. That is the whole story of the mirror, told in one elegant principle. And yet, from this one elegant principle, from this one simple law, emerges all the richness and strangeness and confusion of mirror perception. This I have always found to be the signature of deep physics, a single clean rule hiding endless complexity in its consequences. This is exactly what happened with my matter-wave hypothesis. The rule was simple. If Einstein could show that light, classically a wave, also had particle properties, a momentum, a discrete energy, then, by symmetry, by the same logic running in reverse, should not particles also have wave properties? Should not an electron have a wavelength? The rule was simple. The formula was clean. The wavelength of a particle equals Planck's constant divided by its momentum. One equation, and from it came the explanation of Bohr's atomic orbits, the development of Schrödinger's wave equation, the entire framework of quantum mechanics. One rule, inexhaustible consequences. Nature, in my experience, always operates this way. The deepest truths are always the simplest ones. They are difficult only because we approach them wrapped in the wrong assumptions. So let me draw together what we have learned today, and let me leave you with something to carry with you. The mirror does not flip left and right, it flips front to back. The apparent left-right reversal arises from us, from the mental rotation we perform when we imagine stepping into our own reflection, from the fact that left and right are relative to our orientation, while up and down are anchored to the physical world. The mirror does not prefer any axis. It only obeys the law of reflection. And once you see this clearly, once you stop asking the wrong question and start asking the right one, the mystery dissolves completely. It becomes, in fact, obvious. And that is the greatest pleasure in physics, when the mysterious becomes obvious, when confusion gives way to clarity, when you realize that the strangeness was never in the world but in the frame you brought to it. I have always believed that the role of the scientist, and indeed the role of the thoughtful person, is to question the frames we inherit, to look at the ordinary and ask extraordinary questions, and to be patient enough to find that the answer, when it finally comes, is both surprising and inevitable. A mirror is a simple thing, a flat piece of glass with a reflective coating, and yet it has confused intelligent people for centuries. Not because the physics is complicated, the physics is beautifully simple, but because the question, why does a mirror flip left and right, comes preloaded with an assumption that the mirror does flip left and right, and we never stop to challenge the question before we begin answering it. Challenge the question. This is perhaps the most important advice I can give you. In my own work, the breakthrough came not from finding a clever answer to the questions everyone was already asking, but from asking a different question altogether. Not, how do we describe the motion of electrons as particles? But, what if electrons are not purely particles at all? The mirror asks us to do the same. Not, why does the mirror flip left and right? But, does the mirror actually flip left and right? And the moment we ask that second question honestly, with genuine curiosity, and without the weight of assumption, the answer arrives quickly and cleanly: no, it never did. And the confusion was ours all along. I hope you will look at your reflection tonight with fresh eyes, not as a left-right reversal, but as a front-to-back inversion, a depth flip, a you that has been pressed through the glass and now faces you from the other side, unchanged in every direction except the one that points between you, the one that connects your nose to your reflection's nose, the axis of the mirror. And I hope it reminds you, as it reminds me, that the universe rewards those who look carefully, question honestly, and never mistake familiarity for understanding. Thank you.